In this session, we're going to be covering powers of powers. This is in respect to index expressions. So let's start this off. Let's say we had a question that looks like this: x squared to the power of 3. Now we know any time when something is raised to the power of any number, we are just repeating those numbers and multiplying them again. So in this case, x squared to the power of 3 is going to be x squared multiplied by x squared multiplied by another x squared. Now according to our multiplication rules, we would add all the powers. So we would get x, 2 plus 2 plus 2, and you'd end up with x to the power of 6. Okay. Do you notice a pattern here? Let's see if we can notice a pattern. Let's try another example here. If we have a to the power of 3 to the power of 3, this could be rewritten as a to the power of 3 multiplied by a to the power of 3 multiplied by another a to the power of 3. And of course, if we add all of our powers, we are going to get a to the power of 3 plus 3 plus another 3, which means your answer is a to the power of 9. So moving on to the next one. We found a pattern yet? Let's try this one here. Now see, as the numbers start getting bigger, you really do not want to be doing something like this. You don't want to be going x to the power of 3 times x to the power of 3 times x to the power of 3. Starting to run out of space. Squeeze that in there. Is that 7? Yep, that's 7. So the shortcut method really is to go x to the power, because it's power of power, we just go 3 times 7. 3 from there, and the 7 from there. And so your answer is going to be x to the power of 21. And this is the shortcut method of doing it. Okay, moving on to another example. Let's just make things a little bit more bigger. If we have a to the power of 4 to the power of 10, then obviously we do not want to be writing this in. So the way we would want to write this is a to the power of 4, and because it's power of power, we multiply the powers. And so the answer would be a to the power of 14. Okay, let's start putting some numbers and variables into the mix. So let's say we want to work out 2 to the power of x cubed and the squared. Now if we actually expand this out, we are going to get 2 to the power of x cubed in a bracket, and then we're going to get 2 to the power of x cubed in another bracket. And if we expand this, we are going to get 2 times 2 times x cubed times x cubed. And so the answer is equal to 4x to the power of 6. Now, you might wonder how this 2 turned into a 4, but that's because remember that anything by itself can be raised to the power of 1. So in other words, that 2 is actually raised to the power of 1. So if we still do it another method, we will get 2 to the power of, I'm going to write that 1 times 2, and x to the power of 3 times 2, which means we're going to get 2 squared x to the power of 6, which equals 4x to the power of 6. And as you can see, that's the same answer. Let's try that again. It's the same answer as these two here. So if you have a power of a power and there's a number inside the bracket, then you'll have to raise the power for that number as well, like in this case with the 2. So, do another example. If we have 5x to the power of 7, and let's say we square this thing, so remember that the 5 has a little 1 in its corner, which means this is going to be rewritten as 5 to the power of 1 times 2 multiplied by x to the power of 7 times 2, which means this is equal to 5 squared, and this is x to the power of 14, which means your final answer is 25 x to the power of 14. Okay. Alright, the next idea is looking at not just numbers, but let's say instead of numbers we're going to have 2 variables. If we have something like x cubed y squared to the power of 5. So, as usual, nothing changes. We're still raising things to the power. So x, I'm going to collect the 3 from there, multiplied by, and I'm going to collect the 5 from there. 3 times 5, and of course this is all multiplied by y, and I'm going to collect this time the 2 for the y, and of course that's multiplied by the 5 on the outside. So my final answer is going to be x to the power of 15 and y to the power of 10. So whether it's a number or a letter, it's still going to have the same properties. Okay, what if we have more than 2 letters? Let's say we've got 3 letters. Let's say we have something like a cubed b c squared to the power of 4. Now once again, remember that b has got a power and it's raised to the power of 1, which means this could be written as a to the power of 3 multiplied by, I'm going to take the 4 from outside, and of course now it's times b1, oops, let's try that again, oh, gone the wrong way, b to the power of 1 multiplied by 4, and of course that's also multiplied with c, and that's obviously got 2 times 4. And so this answer now is going to become a to the power of 12, b to the power of 4, and c to the power of 8. Okay, let's do one last example before this end of the session. We'll get 5x cubed y squared to the power of 2. Once again, whether it's a number or a letter, if it's inside a bracket or even if it's by itself, it's going to be raised to the power of 1. So, in this case, we are going to get 5 to the power of 1 multiplied by the 2, which is outside, and all these things get multiplied by x. Well, we've got the 3 there multiplied by the 2. I'm starting to run out of space here, but I'm just going to try and squeeze this in. Y, we've got 2 multiplied by
2. Apologies for the space. Really should learn how to write properly. Anyway, so 5, 1 times 2, well that's just 5 squared. 3 times 2 is 6. And 2 times 2 is 4. But we know 5 squared can be written as 25 x to the power of 6. And final answer is 25x to the power of 6 and y to the power of 4. I think that's enough for this session, guys, with powers of powers. Thanks for watching.